And let's take a look at problem number 11. This is graphing a rational function. So we got f of x is equal to x minus 3 over x squared minus 8x plus 15. And let's first do this on the calculator. Key to doing it on your calculator is if you have more than a single number or single variable on top or the bottom, you have to put parentheses on top and or bottom. So I'll put parentheses around the x minus 3 and parentheses around the bottom part when I plug it in my calculator. So come over here, press y equals, press clear our words on that line, beginning parentheses, x minus 3, closing parentheses, divided by beginning parentheses, x squared, minus 8x, plus 15. And then close parentheses, and then graph. And that would match either B or D, and actually it matches B. So our answer would be B as in Bill. Now to do this by hand, let's talk about that. First thing, for the y-intercept, or wait a minute, sorry, for the vertical asymptote, your first step is to factor top and the bottom. The bottom part is a PSD method, and it factors as x minus 3 times x minus 5. Now step 2 is to factor if possible. They both have an x minus 3, so those are going to disappear. And we got f of x is equal to 1 over x minus 5. Now I'm going to put a little asterisk by this because we're going to come back to that equation. And step 3 of the vertical asymptote is you set your denominator equal to 0 and solve it, and you get x is equal to 5. Now for a horizontal asymptote, the degree of the top, degree is your largest power of x, degree of the top is 1, degree of the bottom is 2. When your degree of the bottom is larger, your horizontal asymptote is y is equal to 0. Now if your degree of the top was larger, there would be no horizontal asymptote. If the degrees are the same, you take the number off of the x of the largest power and create a fraction out of it. Now slant asymptote there is none because the degree of the top would have to be exactly 1 larger than the bottom. So I'm not sure what happened to my display there, but now let's find our y-intercept and our x-intercept. And the one you want to work with when you're well, let's first start with this. The y-intercept, you plug 0 into the other variable, so you plug 0 in for x. Well, the problem with this is you don't want to work with this. You actually want to work with this one right here. So we got 1 over 0 minus 5, which gives us negative 1/5. Now our x-intercept, you always plug 0 into the other variable, but again, the one we want to work with is this one here. So plug 0 in for the y, and you get 0 is equal to 1 over x minus 5. And the reason why is because on this particular case, since the x minus 3's cancel, then we can't go back to the original because they're not really part of it, because that's where it's undefined. And if it's undefined, it's definitely not an intercept. So, well, there is none here. So then we take those, and we got a vertical asymptote at 5. An asymptote is an invisible line your graph will skim at some point. Sometimes it crosses asymptotes. Horizontal asymptote is y is equal to 0, though it'll never cross a vertical. Get like that, and the y-intercept is negative 1/5, like that. Well, if I know it can't be up here, because if it was, it'd cross the y-axis up here. So it has to be down here, without doing any other points. And based upon the asymptotes, I would say this is what it looks like. Now, if this is down here, they can't with your normal ones. You can't have this here, and you can't have this here. So the other piece Now, as you start getting more bizarre rational functions, you can have different variations of that. But then if I compare that, see how, of course I wasn't very close, but without plotting a lot of points, this is a very rough sketch of that.